Hey boys and girls, this is Miss Howard and I want to give you a little bit of extra instruction for the activity that you're going to do in slides called What's My Pattern? Now in this lesson you're going to look for a pattern in a column or row of numbers. This is called a numerical pattern. Look at the word numerical. It has the same beginning as number. So a group of numbers that form a pattern is a numerical pattern. Next, you're going to look for a relationship between the numbers in those two columns that are recorded in a table. And then you're going to study those numbers and identify a relationship between the corresponding numbers and decide on a rule that it follows. Now let's think about what you already know. Here we have an example to guide us through. This is a numerical pattern, which is a sequence of numbers that follows a rule. When we look at this example, we would ask ourselves, how many terms does this pattern have? Now remember, the word term simply refers to the numbers that are in the pattern. This one has 5 terms in it. What rule does this pattern follow? Well, I can see that this pattern is increasing as I go up. So I know I'm either adding or multiplying in order to get the next term. Now, how can I find the rule? Well, I'm looking at the difference between the first 2 terms, and then the difference between the second 2 terms, and then the third and the fourth terms. Now I can see that this increase by 4 in this first step, and then by 8 in the second. So I'm thinking to myself, well, I know that 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32, and this pattern continues. So I can say the rule would be multiply by 2 or times 2. And now we're going to talk about tables. We use tables to organize these numbers so that we can start analyzing them. Here we have 2 number patterns organized into a table so that we can look for a relationship between the numbers in each row. One row is labeled row X, and I have the pattern 2, 4, 6. Now I can see that this is an increasing pattern, and each time it's going up by 2, because 4 minus 2 is 2, 6 minus 4 is 2, so I can see this is increasing by 2 in each step. In row Y, I have the pattern, or the terms, 6, 12, and 18. I know that the difference between 12 and 6 is 6. So I can think, oh, I'm adding 6 more. 6 plus 6 is 12. And then 12 plus 6 more equals 18. So this table is organized in a horizontal format. I can also organize it in a vertical format. And this time we're going to look at our numbers differently. We've already determined the pattern when we go down each of these columns. But now we want to look at these corresponding numbers in the X row and the Y row and see if there's a relationship between those two. And see if that same relationship exists between these 2 corresponding numbers, and then finally the last 2 numbers in each of these columns. So I'm going to look at these 2 and I'm going to say, from changing from a 2 to a 6, it's increasing. So I'm either going to be adding or multiplying by a certain amount. I know that 2 times 3 is 6. I wonder if that's going to work for the next corresponding numbers, 4 and 12. Is 4 times 3 12? Yes, it appears to be true. I'm going to check it on my third one. 6 times 3 is 18. Yes, this is true. So if I'm going to make a rule that is true for every pair of these numbers, I'm going to say X times 3 equals Y. All right, so what does that mean? That means that the number that is in the X column, when multiplied by 3, it will equal whatever is in the Y column. 2 times 3 equals the 6 in the y column. 4 in the x column times 3 equals 12, which is in the y column. So we get this rule, x multiplied or times 3 equals y. Now, somebody out there is going to be thinking, hey, I know about those things called inverse operations. Can't I say 6 divided by 3 is 2? Yes, you can. And so we would word the rule as y divided by 3 is equal to 2. Now let's preview the What's My Pattern activity in slides. Whenever you're working in slides, you're going to have to get out of the present mode and into the edit mode, which is what I'm in now. So the slide that you're going to be looking at will look like this one. And you will see a table with terms written in part of them. You're asked to fill in the missing numbers in the function table. Now, in the previous discussion, we were calling these a table, but these are also called function tables. Now we're asked the question, how is the x column different than the y column? So we know that we're not just comparing the numbers down the column, we're comparing the x column to the y column. So we're looking, how do I go from a 3 to a 6? How do I go from a 4 to an 8? Are they following the same rule? So I'm asked to look at a pattern that I might notice here. All right. There are more than one pattern that you might see here. Okay, while we do know that this is increasing 3, 4, 5, 6, this is 6, 8, 10, 12, just going down the column, we could say that diagonally they're increasing by +2, +3, +4. And then we can also look at from 3 to 6, it is 2 times larger. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, and 6 times 2 is 12. So I know that all the numbers in the y column are twice as much as the numbers in the x column. So what do you have to do with this? Glad you asked. You're going to study these examples in each of these 4 tables, and then you are going to write a rule. Remember, a rule could be stated either 2 different ways. You might say what the rule is going from x to y, or you may reverse it and say what the rule is stated from y to x. Now we're going to do one example here. All right, so I want to take a look at this very first table, and I'm going to see that I'm going from 2 to 6, 3 to 9, 5 to 15, and 7 to 21. I can see that my numbers are increasing, so I know I'm either going to multiply or add the same amount to each of these terms. I know that the difference between 6 and 2 is 4. So I might say, I know 2 plus 4 equals 6. Let me try that in the next set of terms. 3 plus 4 does not equal 9. So that is not true. So I know the rule is not add 4. Let me try something else. I know that 2 times 3 equals 6. Let me try that for the next 2 terms. Is 3 times 3 9? Yes, it's true. Is 5 times 3 15? Yes, that is true. Is 7 times 3 21? Yes, that is true. So I would state my rule. I would click down here. Might have to click twice so I can get a box to write in. And then I'm going to start typing. The term in x, I'll just call this x, times 3 equals y. And then I would move on to my next function table. All right, so the rest of these are done pretty much in the same way. All right, then you're going to have a second slide that you're going to complete. Now in this, some of the numbers are missing in the function table. So once you have decided what the rule is, you're going to fill in these missing amounts. All right, let's take the first one as an example. First of all, I want to look at these terms, 1 in the x, 2 in the y, 6 in the x, 12 in the y. All right, and that's all I have in order to determine what my pattern is. I know that 1 plus 1 is 2, but 6 plus 1 is not 12, so they're not following that rule. I do see that if I double this number, I get 2, and when I double something, I'm multiplying by 2. Is 1 times 2 2? Yes, it is. That's true. 6 times 2, 12? Yes, that's true. Try it with this one. 11 times 2, I know is 22. So I'm going to type in the number 22 in the function table. Now this one, my x is missing. So I cannot just say 32 times 2 will equal x. That would not be true. I'm going to have to think backwards or use the inverse. I know that 32 divided by 2 is 16. So I would put 16 in my x column. And just to be double sure, double check it out, I would ask myself, is 16 times 2 32? Yes, it is. So I would come down here, click, and I would type my rule. The term that is in the x column times 2 is equal to the y column. All right, you're going to do that same thing for these 3 remaining tables. Good luck on this, and I hope you enjoy the activity.